Previously, you learned how to create your own functions. And to explain functions, I made a parallelism with the barista example when you go to order a coffee and you tell to the barista that you want the coffee. Now, I don't know if you thought about this, but when you say you want a coffee, the word coffee is the input you give to the coffee making process. So the barista gets your input and then returns the cup of coffee to you. So we didn't mention this previously, and we also didn't have any input for this getToDo's function. But in this lecture, we're going to enter some input for this function. So there are functions which don't get any input, and there are functions who get an input, or argument, in other words. So for example, the input function gets this argument. The print function also gets this argument. So how can we change this function definition so that the getToDo's function also gets an argument when it is called in here? So that's what we're going to do now. But let's think, what input could this function get? So this function gives us the to-dos. And for the function to be able to give us the to-dos, the function needs to know where the file path is. Now in this case, we have hard-coded here this file path. With hard-coded, I mean we didn't provide a variable, but we wrote the actual value, a string in this case, in the function definition. It would be better to change that into a variable such as file path and then have file path as an argument. So that's how you create arguments for function definitions. And then you provide the value of that argument in here, which would be todos.txt. So if I run the script now, things will work the same. And what will happen is this. I'll execute the script and the interpreter will read the recipe, and then it will check the command, it will execute this, and then it will execute this line here. So that will call the function, this function. And that's when all these lines will be executed. So when the interpreter reads the function, it just reads the syntax, it doesn't execute the lines. But then when you call the function in here, then the interpreter goes back to the function definition and it executes this line. So in this case, file path will be replaced with this value. So basically this is a variable, a local variable inside this function. So inside this function, this is the equivalent of saying now file path is equal to todos.txt. That's what's happening here, although implicitly. So let me remove that. So file path will be equal to todos.txt. Whatever we give here, that is used here. Therefore, the function will open the file, the todos.txt file, will read it as it normally does. It creates the list and it returns the list, and we capture that list in the todos variable here. That's the idea. Likewise, if we used our example here, where we greet the user, this function also doesn't have any input, any arguments now, but if we place here message and we remove the variable declaration in here so that it is not hard-coded anymore, we let the user now enter whatever they like for message. So they don't want to say hello, they want to say hi, and then we print the length of the greeting, or we print the greeting itself. So let me print the greeting itself and to run test, and we get hey by that, and hi because we passed hi there, and the function is printing that new message with the first letter capitalized. So even if it's lowercase, we again get hi with uppercase H because we capitalized the letter there. Now you could ask, well, again you hard-coded the value here. Yes, but you could easily get that from the user. So user entry, and you say input, what greeting do you want? You could ask the user for that and then place here user entry, run the code. What greeting do you want? The user wants good afternoon. Press enter and they get good afternoon. So this is a very simple function, of course. It just prints out the message. But it's just to illustrate how functions work, so they are there as a recipe. Back to our main app. So as we said, when this is called, to-dos goes there, and we want to do the same for the other calls. So we have a second call in here that will also use the same file path, to-dos.txt. We have a third one in here under edit, to-dos.txt, and a fourth one under complete, to-dos.txt. And if I run the script now, and I try the show command, so which will execute this code here. So let's try show, and we get the existing to-do items in the list. So the getToDo function is working well. And that's how you create functions with arguments. One last thing before I close the video is that the terminology actually, when you define the function, this is known as the parameter of the function. But when you call the function, this is known as the argument value. And the argument itself is this. So this is optional. You can mention the argument in here and then assign it the value, but you don't have to do this, so that will also work. But that is also fine. So that is a parameter in the function definition, the argument here, and the value of the argument. Now you have to decide whether you want to mention arguments or not, and there's no specific recommendation for that, so sometimes it makes for a shorter code not to mention the arguments, but just to leave the value there. Other times this could give some more context to the programmer who is reading the code, so you know that this is actually a file path. So that is also fine. It is recommended not to leave spaces around the assignment operator here, so this is not necessary, and it is not recommended because it's too much space, so it would occupy too much space, so this is fine, unlike the variable declarations where it is recommended to have spaces. So leave it or remove it, whatever you prefer. I'll prefer to keep the code cleaner, so I'll just remove that. It is quite obvious that this is a file path, so I think it is not necessary in this case. Thanks a lot. See you later.